Hi, I'm Kian, and today I want to show you how to solve a physics problem regarding one-dimensional motion and using different formulas. So, we have this question. It says the acceleration of a chimpanzee is given according to the following equation, where the equation is a sub x. So I write here a sub x, which is the acceleration, is equal to 24t squared. 24t squared, and this is t. And now the rest of the question is that the initial velocity of the chimpanzee is 18 meter per second at t equals 0. So the first part of the question, so the question 1, it says that we want to determine the velocity of the chimpanzee at t equals 3 seconds. So how do we find the velocity? So for finding the velocity of the chimpanzee, we use a very specific equation, and that equation is that and the velocity, which in this case is v sub x, we call it v sub x, is equal to v sub x sub 0, which is the initial velocity, because in this case we want the specific velocity at a specific time. So we solve for the velocity as velocity, which is v sub x, is equal to v sub x sub 0, which is the initial velocity, and then plus the definite integral from t equals 0 from t equal t sub 0, because it says, if you pay attention, I read that the initial velocity of chimpanzee is 18 meter per second at t equals 0. So we should evaluate the definite integral from 0, and then because we need to find the velocity at t equals 3, the upper value of the integral, upper bound, is 3. And inside is just the acceleration, a sub x, which we said is just 24t squared. 24t squared. So now the first step is to integrate on this. So when integrating 24t squared using the power rule, we get 8t cubed. And we can check our answer by taking the derivative of 8t cubed, and we get 24t squared. And we should evaluate this from 0 to 3. So when we put 3 cubed is 27. 27 times 8 is 216, and then 0, minus 0. Because 0 cubed is 0, and then times 0 is 0. So the value of the definite integral is just 216. 216. This is 0. This is 0. So we found the definite integral, but we want to solve for v sub x. Now we're going to plug in for v sub x sub 0, which is our initial velocity. And in the question, it says that the initial velocity of a chimpanzee is 18 meter per second. So our question becomes much easier because we have to just plug in. So for our final answer, we just get v sub x is equal to the initial velocity, which in this case, I said it was 18 meter per second, and then plus the value of the definite integral, which we evaluated, which was 216. And when we add that, we get 234, and the unit of the velocity is meter per second. 234 meter per second. Now, the next part of the question is that we should write an equation in symbol to determine the net displacement of the chimpanzee, and we should determine the net displacement of the chimpanzee from t equals 0 to t equals 3 seconds. So how do we solve it? So the way we solve this is that for finding the net displacement, we should integrate. So let me write the second part of the question. So we have question 2. So for finding net displacement, we should write it as delta x. Delta x is the definite integral, from, in this case, is from t equals 0 to t equals 3 seconds, because of the question says. So we want to find the net displacement from the chipmunks from t equals 0 until t equals 3 seconds. So the lower bound is 0, the upper bound is 3. And now inside the integral, we should put the expression that we use to evaluate the velocity. So as you know, when we solve for the velocity, which was v sub x, we get v sub x sub 0 plus the definite integral from 0 to 3 of 24t squared. But now, when solving for v sub x, if we consider the bounds to be, if we consider the integral to be an indefinite integral, that means we don't have an upper and lower bound. For v sub x, we get v sub x sub 0 plus the integral of 24t squared. So we know that v sub x sub 0 is just the initial velocity, which is 18, plus the integral of 24t squared, which in this case is 8t cubed. So for our value of v sub x, we get v sub x sub 0, which is 18 plus 8t cubed. So inside the integral for finding the net displacement, we should just plug in 18 plus 8t cubed plus 8t cubed. Let me write it in a better way. 18 plus 8t cubed. And again, I found this values by solving for v sub x, for solving for velocity. Because we should integrate the velocity from a lower to an upper bound to find a net displacement. So now this becomes very easy because we have a easy integral. So integrating 18, we get 18t. And then integrating 8t cubed, we add 1 to the power and we divide, we get 2 t to the 4th power. This is t, this is a plus sign, 2t to the 4th power. And now we should evaluate this integral from 0 to 3. From 0 to 3. So when we plug in 3, we get 54. So when we plug in 3, we get 54 plus 3 to the power of 4 is 81 times 2 is 162. And when we plug in 0, we just get 0. So it has no impact on our answer. 54 plus 162 is just 216. And the unit for net displacement, or in this case delta x, is just meters. So for our final answer, we get 216 meters. Thanks for watching. Please subscribe to my channel for more math and physics videos. Goodbye.